Welcome back. Here we are. We got the moon castle again. This thing is showing up so often it's not even notable or worth talking or being amazed about. Let's get back in here. Project SOAR. I will briefly mention that work continues. I am kind of rebuilding my whole install of the Kerbin Rescaled series. I want to, by the time we get to a certain point in Project SOAR, I want to switch back to KSP Rescaled, and we'll continue work in there. But right now, we're still going in Project SOAR. Let's open this up. I have to thank very, very much Hera Totori. I know I probably mispronounced your name. I'm sorry. I mispronounce names not out of malice, but out of simple ignorance. I just don't know any better. Anyway, the guy, you can go back and look at the comments the comments to the preceding video, and you find that this guy who knows a lot more about airplanes than I do, and is one of the best Kerbal Space Program aircraft designers ever, was advising me where I was going wrong and gave some very helpful suggestions of how to get this vehicle to work. Here we are, ProtoSOAR Echo. Alright, okay, I'm liking it. I will briefly mention that I went ahead and made my launch vehicle into a 3-stage thing, mostly so that the final stage is smaller, because they were getting just ridiculously big. So here we are. We're back with the large dihedral on the wings, which I want for roll stability, which I really do. I always like this idea, and it's a good idea for something that's going to be doing the re-entry. This airplane... Here, let's actually get rid of the launcher and just talk about the glider itself. This airplane, it is upside down and inside out. By upside down, I mean, here we have our vertical stabilizers. We have 2 of them, and they're underneath, or on the ventral surface of the wing. These are the 2, twin rudders down here. So it's upside down. If you literally turn the thing upside down, it looks kind of Klingon-ish. It's a Klingon bird of prey, sort of. Or I guess there's that one of the frigates in EVE Online. I can't remember what it's called, or the faction or whatever. But yeah, it looks kind of like that too. So there it's upside down. Here is the big innovation that I got from speaking with Hera Totori. These guys in here, where I used to put my elevators, these are ailerons. They're not even elevons. These are just for roll. And then I've got these all-moving procedural wing surfaces here at the wing tips, and those are elevators. They only control pitch. Let's illustrate a point. Let's pull this one up here. FAR. We set our pitch setting to 30, which is, whoops, not 300. I don't even know what that would do. 30, which is the maximum amount of control travel the mod will allow. Okay, yeah, I'm not so interested in the graph. I just wanted to get these control surfaces to move. Yeah, okay, that's if you're trying to pitch nose up as hard as it will go. That's the maximum allowable amount of control travel. Look at it from the head-on view, from the relative wind's point of view. They come and they hit these things. Look, these elevators, these are air brakes. It's what they are. I mean, all elevators are air brakes, but these really are. So in actual high speed and high Mach numbers flight, it actually it hits an attitude very similar to that, maybe even as much as that, depending upon exactly what altitude and how fast it's going. And yeah, I will go and I'll demonstrate, but this is stable. The reason that these real-life space planes they don't put the vertical stabilizers underneath, first, that's a materials and structural technology issue. That these things in reality, these things will be getting extremely hot. And it's not such an issue in Kerbal Space Program, since pretty much my entire vehicle has to have the same heat tolerances. And the other issue is real-life space planes, they have much smarter control surfaces than we have available to us in the game. They can have, split control surfaces on either side to be able to control yaw. In any case, yeah, this is a hardware solution to the whole yaw stability issue, and the dihedral gives you the roll stability, and the whole shape of the thing gives you the pitch stability. This is a hardware solution to where in real life spacecraft, they've gone with software solutions. You see, I've also gone here. You can barely see it buried in the wing root. It's in here. Yeah, thermometer. We got I put 2 thermometers in the wing root so we can monitor that. Also worth noting, I've ditched MechJeb and we've gone back to the Kerbal Engineer. Okay, let's actually get out of here and let's get. Again, I'm not going to show you the whole launch. Let's get to this thing in orbit and we'll talk some more about that. Yeah, here it is in orbit. Let's go. Okay, yeah, I was talking about Kerbal Engineer. Take a look at this. So we have a couple of things that have been corrected. It used to be that one of MechJeb's one of its advantages that it had over Kerbal Engineer was that the let me see, we'll actually pull this one up. That's not the one I wanted. How about that one? Yep. Was the customizable, widely customizable little info windows that MechJeb could do that Kerbal Engineer could not. That problem is now fixed. I greatly prefer this style. I believe that Engineer's info windows are superior to MechJeb's. The other issue that Kerbal Engineer used to have, here, let's open this up. Maybe that's not the one I wanted. How about thrust to weight ratio, surface thrust to weight ratio. Boom, let's install that one. Okay, yeah, all right, now I'm going to close the editor. This is the other issue that MechJeb, this is the reason that I initially stopped using Kerbal Engineer and I went and I started using MechJeb, was because whenever using real fuels, and it fixed the way the specific impulse system works, where thrust varies with specific impulse, and at the time Kerbal Engineer could not deal with that. That problem is now fixed. So those were the 2 issues that I had with Kerbal Engineer in the past are now corrected. I also want to briefly mention another mod. Let's take a look. Take a look at this. Planet Shine settings. Planet Shine. You take a look. It's if we go to advanced, if I turn this mod off, take a look at the colors and the bottom of my wings. You can see it's a subtle difference. Let's turn it back on. It's a subtle difference, but it does make things just a little bit more beautiful. This is the actual light reflecting off the planet itself and coming up and reflecting off of our wings. And the light actually matches the color of the planet. I like this mod. I think it is extremely cool. And of course, we've got the distant object enhancement is going on, which is why if I look towards a bright light that the dimmer stars all disappear. And this is a distant planet. Oh, that's Jewel over there. Check that out. Isn't that kind of cool? Let me see, do we have any others? Oh, right up here. There's Moho, there's Duna, there's Eve. I like distant object enhancement. Okay, so what was I doing with this thing? Let's pull this up. I wanted my custom 4. Let's go to flags. This is a custom info window, which I did. I called it a ground target. I want to make a flag that I put at the end of runway 9. I'll make that my target. And I decided that my target, yeah, we've got this is where I was doing experiments with the distance, but then I realized what I actually need to work with is phase angle. Let's pull this one up. Let me see. Here we go. Last time I started like negative 218, actually 700 kilometers short. I was about 15 degrees short. Save that. So let's go. I think this time we're actually going to wait until we get to negative 200 degrees. That's if you're, whoops, I was hitting M for the map button, but I was still in here. Yeah, here's my target. I think I want to wait until I'm around over here. This is like 0 degrees or 360. It's the same thing. And so there's 180 and 20 degrees past that. That's when I want to do my retrograde burn, my reentry burn, and then we're going to fly this thing down here. Whether this example makes it or not, we're recording it and we're uploading it. we got to move on. We got to get this program running, you know? Here we go. Let's close that down. And I believe I figured out how to make this work. So let's go faster. I just want to make certain that this is working. Let me see. Yeah, last time I came down just right around there. It's a little 10 degrees short, huh? Yeah, okay. Yeah, we can make this work. And right there, 360. Okay, yeah, so that is measuring the phase angle to our target on the ground correctly. Am I going the wrong way? I'm looking at the distance. I needed to get closer. Oh, no, I actually need to... No, I need to add. I don't need to subtract degrees from that previous number. I need to add. Okay, so let me see. I was adding... Let's go to 230 degrees. That could have been a disaster. I'm glad I caught that. Point this retrograde. We're going to do 100 meters per second burn. So we're going to drop that delta V down to 217. Right now. Okay, just exactly like that. We'll take a look at that path. Yep, it's pretty similar to the stuff that I was looking at previously. So we are going to re-enter. Let's get everything else configured. We have this other mod, these nano gauges. We actually took a glimpse at these earlier. I've set this up so that I have all these little gauges telling me things that I might want to know about atmospheric flight, which we're going to be entering. We'll leave these windows up. That could have some useful information, specifically our phase angle, distance to target. Really, as in the re-entry, with the practice that I've been doing, several different attempts in trying to dial this in and trying to figure out when to burn for re-entry. In flying this, I'm actually going to take a look at 3 different gauges. I'm going to take a look at my vertical speed, I'm going to take a look at my temperature, but mostly I'm going to be paying attention to orbit. To the speed. I've decided that instead of chasing a specific temperature, which is kind of a flawed idea, what is much more accurate, and also not chasing a specific Mach number either. No, we're going to be decelerating for most of this. What I need to do is I need to chase a specific equivalent airspeed. It turns out that what my goal, if I can do this perfectly, would be to do 110 meters per second throughout the entire reentry. I'm actually doing this keyboard. I've unplugged my joystick and rudder pedals. I believe that this was part of the issue I was running in before, was simple overcorrecting. Part of that is the way the SAS works. If you move one axis with the joystick, then it unlocks all axes. Yeah, okay, see our Mach number increasing again. If we first hit atmosphere, it's like Mach 18 point something. It decreased a little bit, and now it's rapidly increasing. It'll get above 20, and then it'll start going back down. Any second now. It's not going... Okay, there we go. Yeah, now the aerodynamics are not... Or, no, I'm sorry, the torque from the reaction wheel is not able to hold it. So now, all I'm going to do... Let's see, look at it from this angle. You can see the angle of attack this craft has. And look over here, my control, all I'm doing is I'm holding just to pitch all the way up. I'm holding, just keeping my finger on the D button and making occasional small corrections with yaw. That's all I'm doing is I'm controlling it, put the elevator all the way back, and then steering with rudder. Okay, I want to bring my lift vector up. Oh, I may be getting too hot here, guys. If I already got too fast. Too low, too fast. Come on, can we catch this? Okay, I can see my vertical speed coming up. That may have been kind of disastrous. Okay, don't climb. Okay. Now we'll roll over this way. We don't want to climb. I just want to maintain altitude. Oh, we're going to pop Yeah, we're going to pop one of our lights off. Yep. Green nav light burned up from overheating. Oh well, we didn't need that part anyway. Okay, now equivalent airspeed dropping down. That's not what I was wanting to demonstrate. And we're still climbing too much. Okay. Now we're all cooling off. It'll be slightly more unstable now. I've got more, just a little bit more drag on the left wing than I do on the right, simply because we just burned our nav light off the right wing but kept it on the left. Oh well. Okay, that's going to hit 110. Now I'll just rudder it on over the other direction. Look how much easier this is than this incredible fighting the controls every second that I was having to do with the previous aircraft. I am very pleased with this. And what I want to do, see, I'm already very, very confident, just in the trial runs that I've done, that this wing configuration, as suggested by Heratotori, is the overall, this is the configuration that I want to do. I love this view. You can see what it's doing. That I want to do for the subsequent vehicles in this series. So the next thing I want to do after demonstrating that this one will re-enter and it'll be controlled throughout re-entry, and I'm confident that I can at least get it in the vicinity of Kerbal Space Center. Then we want to do something in a very similar configuration, but slightly larger. I'll make one that it'll carry one Kerbal. You know, we'll just, in place of right where this parachute is, that's where I want the bubble canopy of the Mark II cockpit, or I guess we're not calling it the Mark II anymore. Anyway, the inline cockpit. You know, it'll be a vehicle to carry one Kerbal into orbit and back down to Kerbin, or it'll have an equal mass of, you know, we'll remove the Mark II cockpit, and instead it'll carry, I'm thinking mostly, you know, food, water, oxygen, life support supplies up into orbit and carry waste products back down to Kerbin. It just keeps kind of wobbling back and forth in yaw, and it's just ever so slightly uneven drag. I should have a means to just jettison the remaining nav light to balance the thing out. It really, the big revelation is it's about managing airspeed. It's about managing vertical speed and airspeed, and therefore, in my mind, I can relate it to flying that I understand. And this number, this is a higher degree of precision. It's easier to keep an eye on the airspeed than it is to be guessing at this temperature all the time, because the temperature is a direct function of our airspeed and our altitude. So we'll try to, you know, try to regulate the cause instead of watching the effect, and try to think about I'm dictating to the airplane what I want its airspeed to do, rather than responding, trying to rescue it from whatever the temperature is doing to it. Mach 6. Let's just go to just pure wings level flight here for a bit. Take a look at our map. Middle of the ocean. We splashed down there many a time. Thinking that maybe we might be going to undershoot, so I think we'll allow it to pop up and try to get some extra range out of it. Okay, so yeah, as we can see, so we're this slowing down. Look what our temperature gauge is doing there. We're now below 1,000 degrees, and we'll dramatically start cooling off with our lower equivalent airspeed, but especially as we drop below Mach 5. Now, honestly, it's looking, if I had to guess right now, I'd say we're going to undershoot. We'll be around over here. We're not going to make Kerbal Space Center. I should just move Kerbal Space Center over here if that's where I'm going to be landing all the time. Although phase angles, we're off by like 5 degrees here right now. Slightly less. Doesn't seem right. That looks like it's significantly more than 5 degrees. Although at the rate this is going, wouldn't that be funny if this actually, if I hit what this thing was telling me was the correct distance to the phase angle, but but the actual facility isn't there. Yes, these things are not agreeing. My numbers are not agreeing with what my eyes are telling me. Just never a comfortable situation. Just by the numbers, I'm going to hit my goal. I'm going to slow down supersonic at about this time, says 360, or rather 0, and about the time my distance spools down to nothing. Okay, and here we are. According to this, I should be just pretty much just directly over my landing zone, but I'm obviously not. One thing about this aircraft is here we are starting to fly in transonic region with no SAS on. It's fighting me a little bit. With putting the ailerons inboard like this, they don't have as much mechanical advantage. We don't have as much roll authority as some other aircraft. So if you're not careful, that can get you into trouble. It's kicking a fuss a little bit because right here now we are specifically transonic. As soon as we slow down and go just pure subsonic, some of this will smooth out. There we go. Ooh. Turning under parachute. How about that? He's wanting to swoop. That's what he's doing. Yep. And again, the larger scale versions will not be doing the parachute recovery. That's just because this is a little test drone. We're descending kind of fast. That looks kind of hazardous. It's kind of fast, isn't it? Yes, it's kind of fast. Oh, there goes our probe core running. No, what is it doing? Where is it going? Stop! Oh, can we turn this on? Oh, that's not helping. Oh, God. Stop. Something's going to break. I don't feel like going with that. That was giving me epilepsy or something. Okay. Okay. I wish I understood what was going on with this. By the numbers, I should have hit my target just exactly. I think that I actually flew that decently, except for, burning the light off. But come on, man, who needs lights? I think that there's something else went wrong in this system that I don't understand. Anyway, I believe we've demonstrated that this is a viable wing configuration. Thank you, Heritatori, for educating me about what I needed to do. It's an excellent suggestion. And yeah, we're going to do some more videos. We are going to do a functional utility craft that can either carry one Kerbal or carry a variety of resources, and we're going to use them in the KSP rescaled series. But that is not now. That's then. We'll come back later. I'll talk to you then. Goodbye.